Hello and welcome back. Today we're looking at 4.1 polynomials. Okay, so we're going to start off looking at some of the most basic concepts of polynomials, and this is really to be able to move on into factoring and some other things for this chapter. So to start off with, we're just going to, like I said, talk about the very basic building blocks, which at the most basic point, right? One term polynomial, okay, is known as a monomial. Okay, so remember, if you think back, right, when we're dealing with polynomials, addition and subtraction signs are what separate terms. So if you have a monomial, that means you're only going to have one term, which means you have no addition and subtraction signs. Okay, if you have binomials, okay, you're going to have one addition or subtraction sign. And if you have trinomials, then you're going to have two. Now, you could have a polynomial that has way more than that, and you'd have way more addition and subtraction signs. But for most part, our focus is going to be dealing with the 1, 2, and 3 terms. Now, when we're trying to figure out the degree of a polynomial, we want to find the degree of each term, and then whichever term has the highest degree, that's the degree of the entire polynomial. So when we look at a problem like example 1 here, okay, we have this one term. Our exponent is raised to the third power. So since this is raised to the third power, that is the only power that's involved, so that degree is just 3, okay, or the third degree. Okay, so on example 2, okay, we look at this. None of these can be combined. They all have different exponents and variables involved. So we just look at each term by itself. So this term, remember, if there's nothing there, it's like having a 1. So x to the first, y to the first, so 1 plus 1 gives us the degree of that term would be 2. The second term here is a y by itself, so that'd be like a 1, so it's just 1. 3x to the second, we have the second power, so that's a 2. And then here, this is really like a first power there on our x, so that's a 1 plus 2, or 3. So because because the largest one is 3, then that means that is our degree. So again, this is a third degree polynomial. For example 3 here, again, we look at them. Is there anything that can be combined? No, right? X to the fourth, x1, y to the third, no. x2, y to the fourth, no. Z to the second. So then I just want to look at each individual term and find its degree. So this degree on this first term would be was 4. On my second term, I'd have 1 for the x, 3 for the y, so that's also 4. 2 for my x, 4 for my y, so 2 plus 4 is 6. And then here we have just the second power. So when we look through this, which one's the highest? Well, it's the 6th, so my degree on this is the 6th degree. Now that method will always work to determine what the degree of the polynomial is. Now in this next section, right, it says put the terms in order of descending degree of x and state the degree of the polynomial. So decreasing degree or descending degree, either one, okay, right, means we're getting smaller. So we're going to start with our biggest degree for x and work our way to our smallest. So when we look here, we have this x squared, negative x squared, along with this negative x squared. Those two can be brought together to give us negative 3x squared. Our x terms, we have this positive 3x and positive 5x, which gives us a positive 8x. And then that leaves us with just this little minus 4 out in the end there as our constant. So then when we go to find the degree of this, remember, we look at the degree of each individual term. So the degree of this part would be 2 from the x squared. The degree of this would be 1. And then there are no variables here, so the degree of that is just 0. So what degree is this? Well, it's a second degree. Okay, for number 5, okay, we're going to follow the same basic idea. We have this x squared, y squared. We have a plain x squared. We have another x squared, y squared, and we have another x squared over here. So we're going to put our x squared, y squareds together because they as a term will have a higher degree. So x squared, y squared plus 8x squared, y squared, one of these plus 8 of those gives us 9x squared, y squared. And then if we have minus x squared minus 2 more, leaves us minus 3x squared. And then we're left with just this 5xy squared. And then we go through and we look at it and we say, okay, what's the degree? Well, 2 plus 2 is 4. This is just has a 2 by itself, and this would be 1 plus 2, which is 3. 4 is the highest, therefore this is a 4th degree. Okay, for number 6, again, we're looking at, are there any like terms that we can combine? So we have an x squared y z to the third. We have an x squared y z to the third here. But we actually have an x to the third here, so that needs to come first, right? So in our highest degrees. So 5x cubed y squared z squared. Okay, then we have this 3x squared y z cubed that can be combined with this negative 4x squared y z cubed. So positive 3, negative 4 leaves us with a negative 1x squared y z cubed. Then we have a positive 3xyz and a negative 1xyz. Positive 3, negative 1 leaves us with a positive 2xyz. So then I go through and I look at my exponents to add them together. 3 plus 2 is 5, plus 2 is 7. 2 plus 1 plus 3 is 6. And then this would just be 1, 1, and 1, so that gives us 3. So this is a 7th degree. Okay, on the back, the second part of this is just going to ask us to either add or subtract the polynomials. So here we're just simply adding this polynomial to this polynomial. So 3x squared minus 2xy plus 4y squared plus 2xy plus 3x squared. And because this is plus, we don't have to worry about distributing negative or anything, so we can just go right into actually combining like terms. So I have this 3x squared, then I have this 2x squared. Those two can come together to give me 5x squared. This negative 2xy is the only one, so we can bring that down. Then we have a plus 4y squared plus 3y squared. You have 4, you add 3 to it, and that gives us a 7y squared. Now the second part of this problem is the same exact idea, only this time we're subtracting. So this is going to be 3x squared minus 2xy plus 4y squared minus, and we have to be careful here because this is subtracting this whole quantity, our 2x squared plus 3y squared. So we want to distribute this negative to both parts of that. So we really have 3x squared minus 2xy plus 4y squared minus 2x squared minus 3y squared. So now I have a positive 3x squared with a negative 2x squared. Positive 3, negative 2 leaves us with just 1x squared. This negative 2xy, it's the only 2xy, so we continue to bring that down. But now I have a positive 4y squared here, a negative 3 here. So if we have a positive 4, a negative 3, that leaves us with a positive 1. So that's just plus y squared. Okay, and then the last but not least, okay, we're going to look at one that involves some multiplying and some combining of like terms. So the first thing we have to do is distribute what's out in front of each one of these parentheses. And then at that point, we can combine like terms. So x squared times 2y would be 2x squared y. X squared times a negative 3 would be minus 3x squared. Plus 4 times x squared is 4x squared. 4 times 2y would be plus 8y. Now here, if you change this to plus a negative 3y, now we can distribute a negative 3y, and we don't have to worry about distributing the negative throughout it because I'm going to get it from multiplying out this negative 3y. So negative 3y times x squared is a negative 3x squared y. And then negative 3y times a negative 1. Negative times a negative is a positive. So 3y times 1 is just plus 3y. Now we have to look for like terms.
We have x squared y here, we have x squared y there. So we can bring those two together. 2x squared y, negative 3x squared y, leaves me with a negative x squared y. Then I have a negative 3x squared and a positive 4x squared. That gives me a positive x squared. And then I have a positive 8y and a positive 3y, leaves me with a positive 11y. And that's our final answer on that one. So hopefully this was very helpful. Good luck on your worksheets tonight, and I will see you tomorrow.